Computers may seem like geniuses, but they only understand one language binary code. This binary code is a system of zeros and ones that forms the foundation of all digital communication. It's the language that computers use to perform every task, from the simplest calculations to the most complex algorithms. This system of zeros and ones represents everything from your favorite photos to complex software instructions. Each image, each piece of software, and every bit of data is broken down into this binary format so that the computer can process it. Imagine your favorite photo. To you, it's a beautiful image, but to a computer, it's a series of binary digits that need to be interpreted and displayed correctly. Data conversion is the process of translating human-readable information into this binary language and back again. This process is essential because humans and computers speak entirely different languages. While we use words, numbers, and symbols, computers rely on binary code. Data conversion acts as a translator, ensuring that the information we input is converted into a format that the computer can understand and vice versa. Think of it like this. You wouldn't understand someone speaking Mandarin if you only spoke English. The same principle applies to computers. If we input data in our human language, the computer wouldn't understand it without converting it into binary code first. This analogy helps us grasp the importance of data conversion in our daily interactions with technology. Similarly, computers need a translator to interpret the data we throw at them. This translator comes in the form of software and hardware designed to convert our inputs into binary code and then back into a human-readable format. For instance, when you type a message on your smartphone, the device converts your keystrokes into binary code, processes the information, and then displays the message on the screen in a way you can understand. This is where data conversion comes in. It's the unsung hero of the digital world, working behind the scenes to ensure seamless communication between humans and machines. Without it, our interactions with technology would be impossible. It's the crucial bridge between our world and the digital realm. Just as a physical bridge connects two separate landmasses, data conversion connects our human world with the binary world of computers. This bridge allows us to harness the power of technology to perform tasks, solve problems, and communicate with others. Without data conversion, computers wouldn't be able to process, store, or display the information we rely on every day. From the moment you turn on your device to the time you shut it down, data conversion is at work, ensuring that every action you take is understood and executed by the computer. Every click, every keystroke, every image you see on your screen involves this fundamental process. Whether you're browsing the internet, playing a game, or working on a document, data conversion is happening continuously, translating your actions into binary code and then back into a format you can understand. Understanding data conversion allows you to appreciate the scale and complexity of information processing happening within your device every second. It's a reminder of the incredible technology that powers our modern world and the intricate processes that make our digital experiences possible. So, the next time you use your computer or smartphone, take a moment to think about the data conversion happening behind the scenes, making it all possible. At the heart of your computer lies the Central Processing Unit, or CPU, the brain of the operation. This tiny but powerful component is responsible for executing instructions and processing data, making it the core of all computing activities. Inside the CPU, we find registers, small but mighty storage units that hold data the CPU is actively working on. These registers are integral to the CPU's function, acting as temporary storage locations that the CPU can access almost instantaneously. Think of registers like the CPU's pockets, providing lightning-fast access to frequently used information. Just as you might keep essential items in your pockets for quick access, the CPU uses registers to store critical data and instructions that it needs to access rapidly. Why are registers so important? Because they're much faster to access than RAM, the computer's main memory. While RAM is also a form of temporary storage, it is not as close to the CPU as registers are, making it slower to access. By keeping frequently used data close at hand, registers dramatically speed up processing, allowing your computer to perform tasks quickly and efficiently. This speed is crucial for the smooth operation of applications and the overall performance of the system. Imagine you're solving a math problem. You have a set of formulas and basic equations that you need to use repeatedly. You wouldn't constantly refer back to a textbook for basic equations. Doing so would slow you down significantly. Instead, you'd keep those formulas in mind for quicker calculations. This way, you can solve problems more efficiently without the constant need to look up information. Registers work similarly, holding on to critical data so the CPU doesn't have to waste time fetching it repeatedly from RAM. This efficient data handling is what makes modern computers incredibly fast and capable of performing complex tasks in a fraction of a second. There are different types of registers within the CPU, each serving a unique purpose. Some registers hold data, others hold addresses, and some are used for specific instructions. This specialization allows the CPU to manage various tasks simultaneously and efficiently. Understanding the role of registers helps us appreciate the complexity and efficiency of modern CPUs. These tiny storage units are a key component in the intricate dance of data processing, enabling our computers to perform at their best. So, the next time you use your computer, remember the crucial role that registers play in making everything run smoothly. They may be small, but their impact on performance is immense, ensuring that your computer can handle everything from simple tasks to demanding applications with ease. Section 4. A register for every occasion, types, and purposes. Just like we have different pockets for different items, CPUs have various types of registers, each with a specific function. Some common types include instruction register, which holds the current instruction being executed by the CPU. Accumulator, which stores intermediate results of arithmetic and logical operations. Memory address, register, which holds the address of the memory location being accessed. And finally, the program counter, which keeps track of the next instruction to be fetched from memory. Each register plays a crucial role in executing programs and processing data. Understanding their individual functions gives you a deeper understanding of how the CPU orchestrates the complex symphony of operations happening within your computer. Section 5, your computer's address book, memory addresses. Just like we use addresses to locate houses, computers use memory addresses to find specific data stored in RAM. Each memory location has a unique address, allowing the CPU to access and retrieve data with pinpoint accuracy. Think of RAM as a massive apartment building, with each apartment representing a memory location. The address of each apartment allows the CPU to find the right data quickly and efficiently. Without these addresses, accessing data would be like searching for a needle in a haystack. Memory addresses are essential for organizing and retrieving data in a systematic way. They ensure that the CPU can access the correct information when needed, enabling your computer to run programs and perform tasks seamlessly.